Okay, so the next conversation I want to have with you about gases is Charles' law. We want to talk about the relationship between temperature and pressure. It's a lot like temperature and volume. And it's a lot like pressure and volume, except it's different, right? So it turns out, again, the goal for this section here is to consider the temperature-volume relationship, which is called Charles' law. And it turns out these are related in a different way. These are directly related. So as the volume goes up, the temperature goes up of a system. Kind of like pressure and volume, except they were reciprocally related, right? So now we want to assume, of course, that pressure and moles are constant. So we're not changing that. We're only changing volume and temperature. And they go like this, okay? And there's not really a whole lot else to tell you about that. For example, if you have a small fire under this vessel, and the temperature is 200 kelvins, and the volume is 1 liter, when you double the temperature, you're also going to double the volume. All right, so we're going to do that with this equation. V1 over T1 is equal to V2 over T2. And we're going to, of course, solve for whichever one we're not given, right? So let's do an example using Charles' law. V1 over T1. V1 over T1 is equal to V2 over T2. Okay. A balloon has a volume of 785 mils. So volume, and I guess that's 785, and we'll do this in mils. At 21 degrees Celsius, T1. Oops, forgot to tell you, this has to be in Kelvin. So we're going to do this in Kelvin by adding 273 to it, and that's going to be 294 Kelvin. What is the new volume? Oh, the temperature drops to 0. T2 in 0 degrees Celsius is equal to 273 kelvins, right? What's the new volume if we do make that change, if we drop the temperature like that? Well, it's going to be, I got to rearrange this. I'm looking for V2. So it looks like V2 is going to be T2 times V1 over T1, right? A little algebra there. And let's put the numbers in. T2 is 273. V1 is 285. Did I read it? No, it's 785. Oops, that's a 7. $785 over T1, which is 294. 294, which is equal to V2. Let me do this on a calculator here. I'll give you a chance to practice in a second. 273 times 785 divided by 294 is equal to 728.92. 728.928 ... And we got 3 sig figs here, 3 sig figs here, 3 sig figs here. This is going to be 3 sig figs. So it looks like it's going to be reported as 729 milliliters. And there's my answer, 729 milliliters. All right. So let's do a learning check now. I'm going to encourage you to pause the video here, solve this, and come back and compare your answer to mine. Okay, I'm going to suppose you solved it or paused it. You've got some notes in front of you. That's by far the best way to learn. A sample of oxygen gas has a volume of V is equal to 420 mils at a temperature of 18 degrees Celsius. Temperature. $273 is equal to 291, right? In kelvins. At what temperature would the volume of the oxygen, at what temperature would the volume of the oxygen be 640? V2, 640. T2, right? And I know that V1 over T1 is equal to V2 over T2. And so I'm going to flip both of these and say T2 over V2 is equal to T1 over V1. And so T2 is going to be V2 times T1 over V1. Okay? V2 is 640. It's in mils, and that's also in mils, so it's going to cancel out. T1 is 291, and V1 is 420. And I'm going to have to convert this back to Celsius because it's asking for it in Celsius. Right? 640 times 291 divided by 420 gives 443. And there it is, 443. Now, if you want to see what happens, you want to see, I encourage you to do this with degrees Celsius and see what happens. You're going to get the wrong answer. Do it in degrees Celsius and you'll see you do not get the right answer. All right, and I want to do one more learning check here. Pause the video and look at this. Pull your notes out and look at these definitions and fill in the blanks. Okay, I'm going to suppose you paused it, and I'm going to come over here with green. Pressure increases or decreases when volume decreases. Well, P1V1 is equal to P2V2. And at a constant temperature in moles, when one goes down, the other one goes up. So this is going to be increases. Pressure increases when volume decreases. What about temperature? Temperature and pressure go together. When this decreases, this also decreases. Right? What about pressure when volume changes from 12? When volume changes from 12 to 24, when volume goes up, this is going to decrease, right? Because pressure and volume do opposite. They are inversely proportional. And then what about volume and temperature? When temperature changes from 15, when temperature goes up, volume's going to go down. So it's going to be decrease. How do you spell decrease? D-E-C. Okay? I hope that's what you got. If not, then get with me and we'll talk about these at whatever level you're at. Good luck.